What customers are telling us today is that essentially their researchers, their data scientists are coming to them and say, hey, I have this traditional HPC workload, but I want to introduce AI and data analytics techniques to make this workload better. We want to be able to essentially run a simulation. Once we run that simulation in the HPC cluster, we want to take that output and we want to put it into a neural network to see if we can detect any additional patterns. After that, we want to essentially be able to visualize that with data analytics tools so they can get to that insight faster. And so when you look at what's happening today with customers, they actually have two choices. Either they can essentially build 3 different environments and have a dedicated HPC, AI, and data analytics environment, which is very costly. You need 3 times more of the people, 3 times more of the resources. Or what they can do is come and look at the solution that we're proposing to customers and trying to solve that need. The goal here is really to enable our users to use one set of resources, one set of clusters, to enable you to run all those workloads instead of having 3 different environments. And so let me give you an example here of how we're going to do that. So when you look at this today and we say, hey, well, HPC, that's a traditional Slurm job scheduler, and you look at essentially these new workloads like data analytics and AI, and those you don't use the same type of job schedulers. So how do you enable those workloads to cohesively run on one cluster? And by adding Kubernetes and Docker into our architecture, we're actually allowing you to spin up those workloads without having to build a separate siloed environment. Not only that, what we're doing is that we're essentially building a set of scripts and a set of software platforms that allow you to dynamically move those new nodes between essentially HPC jobs, Spark jobs, and then also essentially deep learning jobs like TensorFlow and Horbot to make it simpler for customers to use. So when you have to manage an HPC cluster or you have to manage a cluster of services, you got to look at essentially hardware, software cost, storage costs, but not only that, you also have to look at people cost as well. And so if you have to maintain 3 different environments, you need 3 different teams to do that. You can see that your cost would essentially double or triple. And so our goal here is really to help our customers, come to one efficient architecture, essentially manage one pool of resources, and have one team that manages these different pool of resources. But you're actually able to essentially address all these different workloads with these 3, with these resources that you traditionally haven't been able to do. And so when you look at what we're trying to build here, it's really we're trying to simplify the architecture for our customers. We're trying to make it easy not only to run your traditional HPC jobs, but we also want to make it easier to essentially add data analytics or AI to your current cluster today without having to build an environment, a separate environment, which is more costly.